Hey, welcome back to Math with Patrick. Today is November 2nd, and we're solving problem 306 from the Daily Epsilon calendar. And the answer today should be 2, because that's today's date. So we have concentric circles, I believe, as in they have the same center. One circle is smaller than the other. And we have this kind of relationship here where, let's see, 2a would be this total distance, plus b is going to be that distance right there, is supposedly equal to c. Okay, so this problem is about circles, arcs, radians or degrees in radian measurements, and then apparently it looks like our angle on the inside here, again in radians, is going to just be 2. All right, let's try it out. The first equation that I want to bring up is the arc length formula, where S represents some kind of arc length like this, and S is just equal to r theta. R is the radius, so like here, and theta is going to be the internal or central angle that subtends or just kind of like measures out the arc on the outside here. And for our problem today, the theta is going to be x because x is our angle, so we can replace theta with x. It does look like we have, well, we have 2 circles, so I'm going to use 2 different r's for their radii. I'll use little r for the inner circle, and that means that rx is going to be equal to b, because that's the kind of smaller arc here. And then likewise, c, the greater arc, is also going to be equal to rx, but I am going to use this big R just to represent the longer radius of the bigger circle. And a is just going to be the difference in the radii, right? Because the big radius minus the little radius is going to give us the distance of a. So a is equal to big R minus little r. And hopefully, if I just sub in these values for a, b, and c, I'll be able to solve for x. Let's just see what happens. So 2a, a again is big R minus little r, plus b, b is rx, and then equals c, big R times x. To solve for x, for like this kind of scenario, we'll want to get the x's on the same side as each other. So we'll subtract rx from both sides, or little rx from both sides. Okay, I'm seeing the answer now. And then we can factor the x out from both terms. So we get x times the quantity, big R minus little r, still equal to the left side. And then to isolate x, we can divide both sides by big R minus little r. Oops, that wasn't supposed to be an equal sign, but a minus sign. And then big R minus little r. So we just get x on the right, and then the difference of the radii cancels out, and so we just get x is equal to 2. So what's kind of cool here is that it doesn't matter what the radii are. We could make this inner circle a lot smaller. We could make the outer circle a lot bigger. This feature, I suppose, of this particular diagram does not depend on the radii. It just depends on x being 2 today. So that's a fun problem. I think we're all done. So thanks for watching, and I'll see you tomorrow. Bye.